Okay, in this case, let's consider another case. For example, when we have a ramp, okay, and we have a bicycle, the cyclist will cycling uphill. So in this case, the cyclist will have to exert a certain amount of force required to go uphill. And say, for example, the distance traveled is 50 meters here, this is 40 meters, and this is 30 meters. Assuming the cyclist move up at a constant, probably without the force, but the cyclist moving up at a certain initial velocity of say 50 meter per second, which is actually too fast. Alright, moving upwards, and we are trying to see how far or how high along the incline will the bicycle eventually reach stop. Okay, so when we look at this case, we will need to understand that there is also some form of energy loss along the stretch here, which I'm going to highlight in yellow. Along this stretch, there will be some form of frictional loss. So we are considering a case where there is loss of energy due to friction. Okay, so in that case, then your initial energy initial is equals to energy final, and energy initial is actually your half mv squared, right? And it has to be equals to energy final, which we will assume it to be just mgh, because we say that you come to a stop. So if you come to a stop, your final velocity v must be equals to 0 meter per second. So in this case, you will only be left with mgh, and we want to consider whether is there energy loss. Okay, so now assuming that you realize that you actually stop at the peak, okay, assuming that you actually stop at the peak, then based on your half mv square of initial 50 meter per second, and you actually stop at the top, which is 30 meters. If there's any difference in energy between the initial and the final, the rest must be due to the energy loss. Okay, and if the energy loss we mentioned, because this is due to friction, we can actually use the frictional force times the distance traveled. Okay, and that would give us something along these lines, plus f times 50 meters. Okay, because the region in which frictional force is experienced is actually 50 meters. So all we need to solve this situation now is actually to know the mass of the bicycle and the cyclist. So if we assume that the mass is going to be say 50 kg, for example, so we can incorporate 50 square is equals to 50 times 10 times 30, and this must be equals to addition of such. So then we have 25 2500 is equals to 15123. Yep. So we have 62500 over here, subtract 15,000 is equals to f times 50. Therefore, f is equals to how much do we have? 47500 over 50, and that will give you 950 newtons. Of course, this frictional force is a little bit exaggerated because we I did not have a prior calculation, and these are just numbers plucked on from random. Okay, so this is an example of how you need to calculate, and all starts off with an equation. Okay, and these equations come from this idea that energy is neither created nor destroyed. So total energy at the start must be equal to total energy at the end.